Automatic, Addison.
In this tutorial, we will explore miscellaneous useful features in C++. Let's explore enums in C++, which allow you to create named constants for better code readability and type safety in robotics applications. So we have Visual Studio Code open, and let's create a new file called enum example.cpp. And let's type the following into the code editor. #include iostream. And let's declare our enum class robot state. We'll say idle, moving, grasping, error. Okay, and let's do a method called print robot state. Okay, and let's create a switch state. And let's do case robot state idle. And if it's idle, we do stood cout robot is idle. Stood indel break. Okay, and let's do various cases. So we're gonna do 3 more of these. 2, 2, 3. Let's fix the formatting here. Okay, and the second one is moving. Robot is moving. This one, the third one, is grasping. Robot is grasping an object. This is error. Robot encountered an error. Okay, it looks all good. And now let's do int main robot state current state equals robot state idle. Print robot state current underscore state. And current state is equal to robot state moving. To print robot state current state. Let's go down here, return 0. Okay, so in this code, we declare, include the necessary header iostream for input output, just like we always do. And we define an enum class called robot state to represent different states of a robot. The enum constants are idle, moving, grasping, and error. Using an enum class provides strong typing and prevents naming conflicts. Now we define a function called print robot state that takes a robot state as a parameter. Inside the function, we use a switch statement to match the state and print the corresponding message. In the main function, we create a variable current state of type robot state. And we initialize it with robot state idle. We pass this state to the print robot state function, which prints the appropriate message right here. We then change the current state to robot state moving and call print robot state again with the updated state. Now run the code. So we see robot is idle, robot is moving. So enums provide a way to create named constants and make your code more expressive and self-explanatory. They're particularly useful for representing states, modes, or options in robotic systems. It improves your code readability and reduces the chance of errors. Let's explore how to generate random numbers in C++, a useful technique for various robotics applications such as simulations, sensor noise modeling, and path planning algorithms. Let's create a new C++ file called randomnumbersexample.cpp. Okay, and let's go through it together. Pound include IOStream for our input output. And let's include the random library. And let's include another library as well, ctime. Let's do the main method. And let's do stud srand static cast unsigned int stud time null pointer. And that was our, so by the way, the S right there in srand, it stands for seed. So we seed the random number generator. And now let's generate our random integers. Int random int equals stud rand. Let's do stud cout random integer random int stud indel. Okay, that generates random integer. And now let's generate random floats between 0 and 1. Float random float is equal to static cast float stud rand over static cast float. Rand max. Okay, and now let's do stud cout random float between 0 and 1. Random float. Stud and L. Now let's generate random numbers within a range. So I'm going to do int max value equals 10. Let's do int, actually let's do min value, start with the min value. Okay, and I'm going to do int max value here. It's equal to 50. And let's do int random range is equal to min value plus stud rand percent symbol, and then max value minus min value. Okay, plus 1. Save. Okay, and then below here, let's do stood cout random integer between min value and max value. Random range. Stood and L. Okay. Let's put this above and just move this down below. Okay, let's keep it like that. All right. So now we're just going to save this. Okay, so there we were generating a random integer, and now let's use our random number generator. Random device RD, and we're going to use the Mersenne twister random number engine. Okay, don't need to worry about what that is, but let's do this like that. MT 19937, and then gen RD. Let's go slowly, go slowly. Now let's do stood uniform real distribution double. Now I'll explain all of this in a moment. Okay, double random double. So you go to dis gen. Stood cout random double between 0 and 1, and then Mersenne twister. Random double. Stood and L. Okay, and then return 0. So in this example, we start by including the necessary headers, IO stream for input output, random for the Mersenne twister random number engine, a fancy way of just saying the random number generator, and then C time for seeding the random number generator. So first we seed the random number generator right here. All right. And then the current time, we use the current time right here from stood time null pointer. And so this, why do we seed? Well, seeding ensures that we get a different sequence of random numbers each time we run the program. So that's why we do this seeding, and we seed it with the time because the time is constantly moving. So we're always doing a new seed. All right. We then generate a random integer using stood rand, and we print it to the console. Then we generate a random float between 0 and 1 by dividing a random integer from stood rand by the maximum value rand max. So to generate a random number within a specific range, we use the modulo operator, is percent symbol, and that gets us a random value between min value and max value, and then we add min value to shift the range. So for more advanced random number generation, we use the Mersenne twister algorithm, which provides better statistical properties than the standard rand function. And you can see that right here. It's just another way to generate random numbers. We create a std random device object called RD to obtain a seed value. We initialize a std MT 19937 by convention, generator gen, with the seed, and then we create a standard std uniform real distribution object called dis, okay, to generate random doubles between 0 and 1. And then finally, we generate a random double using the disgen, and we print it to the console. All right, so now let's run the code. So you can see here, we've got random integer, random float, and that's it right there. And then we have our double down here. So integer, our float, and we keep running it. You can see we're going to get different numbers each time. Why? Because we're seeding it differently each time. Pretty cool. So if you want a good statistical distribution of random integers, use this second method using the MT19937, this Mersenne twister random number generator. Otherwise, you can just use the standard random rand function right here. All right, which is stock standard. So we've covered a lot of ground in these tutorials, from basic C++ concepts to advanced concepts. And you need to know that each of these features plays an important role in robotics programming, whether you're working on motion control, sensor processing, or complex autonomous systems. Remember that writing good robotics code is more than just making things work. It's about writing clean, efficient, and maintainable code that can be deployed reliably in real-world scenarios. So don't be afraid to experiment with combining different features that we've covered in these C++ tutorials to solve your complex problems. The skills you've learned in these C++ tutorials will serve as a strong foundation for your robotics programming journey. Thank you for watching. Thank you for following along with these tutorials. And as always, keep building.